All right, picking up where we left off, as I always seem to be starting the videos with that phrase, is question 29a. Right, so if 5 moles of A and 3 moles of B are combined in the following equation, 2A plus B makes C, what is the limiting reagent? Now, I want to point something out, that anytime you are given amounts of both of your reactants, that means that you're going to be looking for a limiting reagent. Okay, if you're given, let me say that again, if you're given the amounts of both reactants, you need to look for a limiting reagent. In this case, we're specifically being asked for that. Okay, so our strategy find out which reactant gives less product. Okay, that's your strategy for any limiting reactant problem. Do the stoichiometry for each reactant. Figure out which one gives you less product. Okay, so I'm going to start with the 5 moles of A. Okay, and I want to find out how many moles of C do I get. So I have 2 moles of A in my equation, 1 mole of C. So that means that A will give me 2.5 moles of C. Okay, now let's take a look at how many moles of C we get from B. Right, we're given that we start with 3 moles of B, and there's 1 B and 1 C. Right, so from moles of B, I would get 3 moles of product. Okay, 2.5 is less product. Okay, so A is limiting. Okay, the other thing that we find out from this is that from the limiting reactant, we also find out a thing called theoretical yield. Right, so by doing this process, I learned 2 pieces of information. I learned what is limiting and what the theoretical yield is. Okay, so whatever gives you less product is the limiting reactant, and that amount of product is the theoretical yield. Okay, so let's look at 29b. So if 5 moles of A and 3 moles of B are combined, how many moles of B are consumed? Okay, so here again, you're given amounts of both. Now we just did that in the previous problem. Okay, and we found out that 2.5 moles of C can be made. Okay, maximum. Right, that's what theoretical yield means. So I'm going to run out of A before I run out of B. And A dictates how much product I can get. Okay, so if I want to know how much B got used up, now we're back to problems that were much earlier in these videos of if I make 2.5 moles of C, how much of B was used up? How much of B was consumed? Now it becomes a simple stoichiometry problem. So our relationship of C to B is 1 mole of C for 1 mole of B. So we find that 2.5 moles of B are consumed to make that much product. Okay, so the maximum amount that I can make of C was 2.5 moles because that's dictated by the amount of A that I have. So how much B went into that process? 2.5 moles. We started with 3 moles. So if we started with 3 moles and 2.5 are consumed, that means that we have 0.5 moles left over. Okay, or we say excess. Right, so the question specifically asked how many moles of B are consumed, and it's 2.5. So that's our first answer right there. All right, so I want you to give this video a pause, see if you can work out the problem on your own, and then come back. So, dissecting the problem, okay? So this time we're not specifically asked what's the limiting reactant. But you know, if you're given the amounts of both of your reactants, 30 moles of phosphorus and 30 moles of chlorine, that this becomes a limiting reactant problem. Okay, so we want to find the limiting reactant. And the way we're going to do that is by finding what gives us less product. Okay, so I'm going to start with each of my reactants in turn and figure out how many moles of phosphorus trichloride they will give me. All right, so we start with 30 moles of phosphorus. And I'm going to put phosphorus on the bottom because I want that to go away. So there's 2 moles of phosphorus in the equation and 2 moles of phosphorus trichloride in the equation. So from the amount of phosphorus that I have, I could possibly make 30 moles of phosphorus trichloride. Now let's do the same thing with the chlorine. Okay, so I'm going to put chlorine on the bottom, and there's 3 moles of chlorine for every 2 moles of phosphorus trichloride. Okay, so again, our moles of chlorine will cancel. So we find out that that much chlorine will give us 20 moles of phosphorus trichloride. So less product, right? That also tells us the theoretical yield. Right, so chlorine is limiting. And so it dictates how much phosphorus trichloride we can get. And the answer is 20 moles. So again, give the video a pause, come back and see how you did. Okay, so let's take a look. So hydrogen gas and chlorine gas react violently to form hydrochloric acid, as shown in the equation below. How many moles of hydrochloric acid can form from the combination of 10 grams of H2 and 50 grams of Cl2? Right, here's your clue. What kind of problem you have. 10 grams of H2, 50 grams of Cl2. Right, you're given the amounts of both reactants. That means that you need to do a limiting reactant problem. All right, so if it's a limiting reactant problem, find what gives less product. Okay, whatever gives less product, that equals our theoretical yield. And our theoretical yield is the maximum amount that we can make with the starting components. Right, so this time we're starting with grams. Okay, and we're asked for moles. So all we have to do is convert our grams of reactants into moles and then calculate moles. Okay, that's all we have to do in this problem. Right, so we have 10 grams, so I'm going to start with each of my reactants in turn and figure out which one gives me less product. So 10 grams of hydrogen, and I need to convert it to moles. So our molar mass of H2 is 2.02 grams per mole. All right, so my grams will cancel. Now I want to go from moles of H2 to moles of HCl. Right, so in our equation, there's 1 mole of H2 and 2 moles of HCl. So I'm going to find that that much hydrogen will give me 9.9 moles of HCl. Right, now I'm going to do the same thing with the chlorine. We're given 50 grams of chlorine. Okay, I need to convert that to moles in order to get to moles of HCl. Okay, my relationship is through moles, so that has to happen that way. So my molar mass of Cl2, remember there's 2 atoms of chlorine there, so 2 times 35.45 gives me a mass of 70.9. And I put grams on bottom because I want grams to cancel out. Now I'm going to go from moles of Cl2 to moles of HCl. So I'm going to put moles of Cl2 on the bottom and moles of HCl on the top. And I'm going to find that that gives me 1.41 moles of HCl. Okay, the one that gives me less product is the limiting reactant and tells me the maximum yield. Right, so it looks like that is our 4th answer from the bottom, or from the top, our 4th answer. Okay, I'm going to go ahead and give this video a stop. We'll come back with one more video to finish up our problems on this chapter, and we'll approach the idea of percent yield in our next set of videos, or just our next video.